Dear students, so this is the fourth problem of first order linear differential equation. Okay, so the first three problems we have already solved in previous videos. I have already explained how to solve first order linear differential equation, but then also we are discussing several problems. The reason is quite simple. Reason is that practice makes man perfect. Get it? Actually, at the end of each video, I give one practice problem for you. You're supposed to solve that problem. Okay, and if you have any difficulty or if you want to cross check your answer, then you need to watch my next video. In that video the problem will be solved. I know that in all first order linear differential equation, if you know the technique, then also the adjustment are different, functions are different, so that's why I'm discussing several problems. But I always suggest, don't watch my video blindly. Getting? You're supposed to solve on your own first, and if you fails to solve, then only go to my video and you will get the complete answer. Okay, so let us start to discuss this problem. See, let me tell you again the standard format of first order linear differential equation. The format is dy by dx plus py is equal to q. It's quite simple. Only three terms are there: first, second, third. Okay, out of these three, two terms lies in left hand side and one term lies in right hand side. Okay, dy by dx must be a single term, getting dy by dx. So let us check the given differential equation is in this format or not. No, definitely. Since in left hand side of equal to sign we have a single term, but in right hand side of equal to sign we have two different terms. Okay, so let us make necessary changes. What do you think? Out of these two, one term must be here, must be on left hand side. So what do you think? Which term shall I bring here? Y hyperbolic sin x. Since y should be in left hand side, so let us bring this term on in left hand side. So therefore, let me write, we have dy by dx hyperbolic cos x. I'm bringing that term here, plus y hyperbolic sin x is equal to 2 hyperbolic cos square x hyperbolic sin x. Okay, so tell me, does it look like this? No. We want dy by dx only single term. Getting? We don't want any multiple of dy by dx, but here we have a multiple of dy by dx which is hyperbolic cos x. So there is very simple method to remove this hyperbolic cos x is to divide entire equation by hyperbolic cos x. So dividing, let me write, dividing both sides by hyperbolic cos x. So let us see what will happen. If you divide by hyperbolic cos x, this term will get cancelled, plus y hyperbolic sin x upon hyperbolic cos x, 2 hyperbolic cos x hyperbolic sin x upon hyperbolic cos x. Okay, so hyperbolic cos square is there, my mistake, hyperbolic cos square x hyperbolic sin x into hyperbolic cos x. So let us cancel out the terms if possible. Dy by dx we have plus hyperbolic sin upon hyperbolic cos, which is hyperbolic tan, so y hyperbolic tan x. So this is equal to hyperbolic cos x will get cancelled. You will have 2 hyperbolic cos x into hyperbolic sin x. So tell me, this differential equation looks like this: dy by dx, right, multiple of y which is a function of x, and in the right hand side also we have the function of x. So it is a perfect first order linear differential equation. So now the question is, what is our p and what is our q? We must note down that thing. So let me write. So here p means multiple of y which is hyperbolic tan x, and q, which is this right hand side, 2 hyperbolic cos x hyperbolic sin x. So I got p and q. So the next step is to find integrating factor, whose formula is e raised to integration p dx, and finally we go for the solution. The solution is y e raised to integration p dx integration e raised to integration p dx q dx plus c. Okay, so let us go for integrating factor. So let us find integrating factor. Integrating factor, I will go for directly e raised to integration p dx. e raised to integration p is hyperbolic tan x dx. Okay. So now the question is, what is integration of hyperbolic tan x? So generally we prepare the formulas of regular tan, regular sine, regular cos. But when you have the hyperbolic functions, okay, we feel difficult because we don't know their formulas of integration and derivative. But it is quite simple. I will tell you one simple thing. Integration of hyperbolic sine is hyperbolic cos. Integration of hyperbolic cos is hyperbolic sine. That's it. In case of derivative also same formula we have. Derivative of hyperbolic sine is hyperbolic cos. Derivative of hyperbolic cos is hyperbolic sine. There is no any minus sign. Getting? So we have very simple formula. But see, I didn't tell you anything about hyperbolic tan. So let me do the same thing in rough. What we have, hyperbolic tan x. So basically hyperbolic tan means hyperbolic sine upon hyperbolic cos. Agree? And we are familiar with this formula, integration f dash of x upon f of x. This is our log f of x. So this is one of the favorite formula. Okay, why I'm saying favorite? Since frequently we use, so that's why this is our favorite formula. So same thing appears here. In denominator we have hyperbolic cos, but its derivative, which is hyperbolic sine, appears at numerator. So we can apply this formula, and this formula says its integration is log of denominator, that means hyperbolic cos x. So finally we got its integration is, let me write here, e raised to log hyperbolic cos x. Okay. Log and e will get cancelled and you will have hyperbolic cos x. So very simple thing we got. Okay, hyperbolic cos x. So finally we got an integrating factor. So let us go for the last part, which is the solution. Okay, so let me remove this part. We will have enough space. Okay, we will get enough space to so write the remaining part of this problem. Just a minute. We have this space. Let us use solution. Is, yeah, try to say what is solution. Y e raised to integration p dx integration e raised to integration p dx q dx plus c. Okay, let us put the values there. Y, what is e raised to integration p dx? Yeah, we have calculated, which is hyperbolic cos. Same thing. What is q? Where is my q? Q. Yes, 2 hyperbolic cos x, hyperbolic sin x. 2 hyperbolic cos x, hyperbolic sin x dx. In left hand side, there is nothing to do. It is already solved. Our target is to solve this integration only. Okay. So it is always better to take the constants outside first. I can see 2 there, so I am going to take it outside. 2 I will take outside. Let us make it more simple. Hyperbolic cos, hyperbolic cos square x, and there is one hyperbolic sin x dx. Okay, again there is a product of 2 functions. Now the question is how to solve. When there is a product, you should go for the product rule, that means u into v, which is integration by parts. Okay, but it is little bit difficult and it is not applicable here. Second option is substitution. In last videos I have already told you how to find or how to identify what I need to put. The simple technique is, whatever you are going to put, its derivative should be adjustable or it must be present near to it. If I put hyperbolic cos x is equal to t, its derivative is hyperbolic sine, which is just next to it. So I am going to put hyperbolic cos x is equal to t. So I say that integration suggests us what I need to do, okay, how to solve it. It gives hint to us. So it is giving hint to me, but you must know the formulas of derivative and integration, then only you will get that hint. If you don't know the formula of derivatives or if you don't know the formula of integration, then you will feel difficulty, okay. So I'm going to put hyperbolic cos x is equal to t. When you put anything, our first task is to find derivative. What is derivative of hyperbolic cos x? It is hyperbolic sin x dx. Derivative of t is 1, so it is dt. So hyperbolic sin x dx will be replaced by this dt only. Okay, so let us solve. So y hyperbolic cos x. Okay, I'm putting in right hand side only, huh? Not in left hand side. 2 integration. It is t, right? So t square. Both of them will be replaced by dt plus c I supposed to write everywhere, plus c. Okay. What is the integration of t square? Are you familiar with this formula? Integration x raised to n. The formula is x raised to n plus 1 upon n plus 1. Okay. Whatever the power, we increase it by 1, and the same number we write in denominator. So power is 2. Increase it by 1. So t cube by 3 plus c. Right. So it is 2 by 3 t cube. But that variable t, that variable we have taken, no, it is not a given variable. So what is its value? Original value is hyperbolic cos x. So at the end we supposed to write it. Okay. So t is hyperbolic cos x. So it is hyperbolic cos square x plus c. Okay. And the left hand side I have already written here, y hyperbolic cos x is equal to 2 by 3 hyperbolic cos square x plus c. So we got the final answer. Okay. So now after that, I'm going to give you one practice problem for you. You're supposed to try that problem on your own. In case of difficulty, you can write to me, or in next video, you will get its answer. Okay. Just make a screenshot of it and be ready for the practice problem. So this is a practice problem for you. Try to solve this problem on your own. Okay. And you will get its solution in my next video. Thank you. See you.